So before I start talking about the LU-Factorization, you are familiar with the equation AX is equal to B, yes? What if I told you that equation is the LU-Factorization, in which the square matrix A is expressed as a product, and A ends up being equal to LU? Well, where L is the lower triangle, which means all entries above the main diagonal are 0, and the square matrix U is the upper triangle, which means all entries below the main diagonal are 0. So let me give you guys a visual representation where we have L is equal to A sub 1, 1, A sub 2, 1, and A sub 2, 2, and 0. Or for a bigger matrix, it's just going to look like this. The main pattern is that the main pattern for LU factorizations is the location of the zeros, where you have zeros in the top corner, or in another case, you end up having zeros in the bottom corner. And it's all gonna come back to us very soon after this example. Well, this isn't really much of an example, it is more of a guideline. And that's pretty much what LU factorization is. So if an n by n matrix A can be written as a product of a lower triangular matrix L and an upper triangular matrix U, then that just means A is equal to L times U, and the equation is an LU factorization of A. Now, let's use a more numerical example. Okay, say we're given these two matrices. Aside from the product not being given, what do we know about the zeros? And if you said they're in very specific corners and they probably mean something, you are probably correct. Well, you're definitely correct. So which one's the lower triangular matrix and which one's the upper triangular matrix? Well, what happens when there's a 0 in the top right corner? Let's go back, and it turns out the L is our lower. The L is not our lower triangular matrix, but instead it's the. Oh yeah. This would be our L. And therefore, with that out of the way, this would be our U, where L is the L is the lower triangular matrix, and U is the upper triangular matrix. And just for miscellaneous matters, we're going to fulfill the product of the two matrices, and there we have it. It's all a matter of identifying which one's which. Okay, so we're given two 3x3 matrices, and it's pretty much the same example as the last one, but it's just bigger. So which one is our lower triangular matrix? And if you said it was this one, you'd be correct. Therefore, this leaves this matrix as the upper triangular matrix. And to remove ambiguity, the matrix product is simply the following. And there you have it. We now can do LU factorizations. As you can see, it's not that insane. You guys can definitely do this, and it won't take much practice to master.